All right. So, well, this is not working. There we go. All right. So earlier today, as Tim said, we've heard a lot that when we transition to the cloud, we were told treat servers as cattle and not pets. And that traces back, I don't know, 15 years, something like that. But I don't agree with that anymore. I think we need to treat servers like roaches. So I'm going to talk about iRobot and me, what we need, what we're building, and especially going to serverless ops, which is something that I don't think gets enough focus. And then, do a little looking forward. So we're iRobot. We make the Roomba. We also make some hard floor care products like the Brava, the recently introduced Brava Jet. We also make some other things. We make a pool cleaning robot and a gutter cleaner called the Luge. It sits in your gutter and sweeps all the leaves out. It's pretty fun. We also make a $200 Roomba-based hacking platform called the Create. That's a fun one. We're global. We're in over 100 countries. Only 40% of our business is in North America. And we may be on 7 continents. There are Roombas that have their time zone set to Antarctica. So that's happening. We're high volume. We've sold, I don't know, the public numbers are 2.4 million robots. So we've got a big fleet out there. Only the top of the line is connected right now, but you'll pretty quickly see that roll through our whole product line. Me, so I'm a cloud robotics research scientist, the buzzwordiest title. I do R&D, I work on cloud architecture, work on our IoT and smart home directions. And I've got a background in a lot of things, UAVs, surgical robots. I was a physicist at one point and a stage carpenter. So a lot of things. What do we need as a consumer IoT company that has a mature market? So we're an IoT smart home company, and one really non-intuitive thing is that from the consumer's perspective, IoT may not involve the cloud as they think about it. And this is really not intuitive. It helps if you think about it as smart home, that the consumer may never interact with their IoT device from outside their home. The cloud may just enable functionality for that device that they're not connecting to. They're only touching it locally, interacting with it locally, and it's going to the cloud, and they have no idea. This is especially true of robots. So robots can get a lot smarter when they're cloud connected. That's what I do. But users may not actually see that as part of the fundamental acting of the robot that they're aware of. We're an enterprise. We need global, scalable, secure, audible infrastructure, all that boring stuff. So for us, again, cloud infrastructure is undifferentiated heavy lifting. Our big data stuff, being an IoT company, that may be more relevant, so we may be more interested in being more involved in infrastructure for that. But this is where serverless architecture comes in for us. That's for our customer-facing side, we don't need it. So that's why I'm here. And again, our development is limited mostly to our business logic. And the real trade-off, the thing that people don't really talk about, is that what you're doing is you're accepting inefficiencies in the available offerings in exchange for vastly reduced ops and dev complexity, right? You're sort of making that trade-off. That's the downside. So in our cloud architecture, what we're serving is users, apps, and robots. So users may have multiple apps. They have a phone and a tablet. Users may have multiple robots. Robots may have multiple users associated with them, and it may not even be an isolated household. You could imagine a cleaning service that brings a Roomba along while they're mopping your bathroom, that kind of a thing. We also have countless apps. So when you set up your robot with your app, you push some buttons on the robot, you connect it to your app, and you don't have to create an account. But we still need to authenticate that app to the cloud, even though there's no user-defined secrets involved. So we'll talk a little bit about the complexity that inspires. So we have local connections. This is also a sort of different thing. The apps can talk to the robots locally. That's important for provisioning. But also, if you're home and your internet's out, you should still be able to talk to your robot. There's a company that makes a connected alarm clock that won't go off if your internet is out. That's just a terrible idea. So we have things that happen offline that the cloud doesn't see immediately. So we also need to react to that. This link is trusted. You have to push physical buttons on the robot for the robot to accept a connection from the app, and then there's secrets exchanged. The app also talks to the robot also talks to the cloud. That's mutually authenticated. That's a trusted link. On the other hand, we can't necessarily trust the app, at least not initially. But because we have these two trusted links, we can pass secrets along that chain, and then we can trust the app through the sort of triangle of trust. We have two entry points for our cloud, API Gateway and IoT. Most of you are probably very familiar with API Gateway, probably not with IoT. Maybe if you're doing some real-time interaction like chat with users, you might consider using it. As for credentials, this is where things get complicated because robots aren't users, they're devices. And so they don't actually have AWS credentials to interact with the cloud. They have certificates and private keys, which means they can only authenticate with AWS IoT. You can't even do API Gateway custom auth because the cert is not available to the custom authorizer. It gets eaten up by CloudFront. IoT allows you to bring your own certificates for devices. This is really big for us and something that you won't find with a lot of IoT cloud providers. The reason for that is that the private keys that we generate for the robots travel about yay far in the factory and get burned on the robot and then disappear from anywhere else. If we were provisioning them from AWS, we'd have to sort of batch, create a bunch, transmit them through the Great Firewall of China, and make sure that we did that in a way that never interrupted our manufacturing operations. Should be a pretty tall order. For anything else that the robot needs to talk to the cloud about, like getting stuff from S3, we use pre-signed URLs that are delivered down through the IoT service. We also have to do over-the-air firmware updates. That's actually a really hard problem that AWS is not solving for us. That's another complexity we have to deal with for robots. The apps get cognito identities. This is all pretty straightforward, except for that accountless functionality bit. Basically, the robot gives secrets to the app that the app can use to authenticate itself to the cloud. That uses that triangle of trust thing I mentioned earlier. We also have Active Directory federated sign-in. We serve that through API Gateway. There's a little tip here for small user base web applications. If you're doing it single page out of S3, you can proxy it through API Gateway. Just use the service proxy integration. And then you use relative paths in all your API calls. And then your client and backend will always be in sync. And you can even run multiple versions at the same time. Kind of handy. For computation, we use lots of AWS services. All our computation is in Lambda and IoT rules. IoT rules are nice because they're free. So if you can actually do the computation there and turn it around without having to hit Lambda, you don't even pay for it. So that's nice. We use a lot of SQS queues. And the reason for that is that we have a lot of mission critical and business critical logic that we need to be guaranteed will complete eventually. And so they end up in SQS queues. So you can imagine how the lack of Lambda integration is killing us. Our storage is all in DynamoDB and the storage that IoT provides for us. There's a way to get the AWS WAF in front of API Gateway, but it's like a complete Rube Goldberg machine. But I'm happy to explain it if you're interested, because putting a WAF in front of your API Gateway is a really smart idea. Even if you use throttling, because the throttling is across all users, one user can DOS everybody else. So giving a WAF to get some visibility on that and be able to blacklist people is key. The asterisk here, Elasticsearch, RDS, these kind of services that are serverless-ish, right? They have servers. You have to provision an amount of capacity, which you have to do with DynamoDB as well. These are kind of like not quite as serverless-y as I would hope. So the problem with serverless is that your component graph very quickly becomes just your call graph. So it gets super complicated. This is part of the service that manages determining which robots you need to send an over-the-air firmware update to. And this is not actually sending the firmware update. This is just determining them, creating that deployment, and readying it to be sent out to the robots. This upper part is actually going away. We can use Elasticsearch for that instead, and with the Elasticsearch integration out of IoT rules, we were able to remove that without adding cost to ourselves. But it still gets very complicated when you're trying to iterate in a single-threaded manner over 1 million robots. So for these enterprise needs, scale, no problem, it's serverless. Well, there are limits, right? Maybe you need 30,000 concurrent executions, but you have to wait till Monday. CloudWatch events is the most annoying thing. The scheduled invocations are, you get 25 of them, and each one can have 5 events. That's not enough overall if you want as many queues as you can possibly think of. And so you have to do some tricky things where different deployments share the same queues by sharing names and stuff. It gets annoying. Yeah. Global is kind of the biggest downside to serverless. You have regional availability. We can't deploy anywhere where AWS doesn't have IoT, which under the hood probably relies on pretty much everything else. And so we sort of have to wait until they go live, whereas EC2, available everywhere. And you get vendor lock-in, which we're talking about how to get around that, but I think that going serverless, the more you're away from the basics, the less you're going to have flexibility. The security is through a WAF, through CloudWatch, through third-party tools. Although for auditability, you go through CloudTrail, there's very little in the way of third-party security tooling to analyze your serverless architectures. That's a huge area of opportunity. So ops, again, is this thing that I don't see talked about a lot. We're away from all these cables, but as I showed earlier, your component diagrams are going to turn into that. And so we want to have infrastructure as code and have build artifacts. Expectability, when I deploy it, be able to track it back to your build artifacts. You want to be able to deploy from a dev machine before you commit, or suck it right out of a repo. You want to be able to, oh sorry, that was the second one. Working directory or git repo. Before that, you want to be able to deploy either locally from your dev machine that you control, or in an automated fashion from a test server. And then you want auditability. You want to know that your infrastructure is secure, both sort of from the outside and from the inside. You also want the billing. You want to check that your cost modeling matches what's actually happening and what you're actually being billed. So for us, that means CloudFormation is great. The slow is okay. Other frameworks like Serverless, Sparta, they're all great. I like them a lot. We took a very long, hard look at serverless when we were considering this. They all are oriented towards web frameworks, like being a web framework. And to do that, to enable the rapid iteration of getting a product really out quickly, they pull the coordination off of the cloud and onto the developer's machine, which doesn't give us quite the visibility that we want to have as a corporate organization. So to do this, we use CloudFormation, and we use a lot of custom resources to deploy and manage these arbitrary resources, things that they don't support, that Rube Goldberg of API Gateway and WAF. We want to give CloudFormation some syntactical sugar. There's not a function, there's not an easy way to get the ARN of a DynamoDB table in a CloudFormation template, which is crazy, but we want to make that easy. We still need to deploy and manage all these custom resource lambdas. Still need to deploy artifacts into S3, like the Lambda source code, CloudFormation templates, any secrets that you need in there. So we're rolling our own tool. It sounds very closely aligned with Flourish, and we're very interested in, is that something we could transition to and drop something that we have to maintain? The reason why we call it Clouder, that a Clouder is the group noun for cats. And everyone here knows managing AWS resources is like herding cats. And so the way that this works is you start with your source, whether that's, again, in your file system or in a repo somewhere. You build your Lambda source code, so we're Python, so you pip install all your requirements. You have some, common code that sits between your Lambdas, and if there's a make file, we'll build that for whatever kind of random stuff you need to do. We deploy that into S3. Then you want to suck down all those S3 URLs that you have back into your CloudFormation template in the appropriate places. The reason for that is you can't predict those URLs in advance because we make it content addressable in S3, so you got to hash the content, and you don't know what that's going to be ahead of time. Then you do the same thing with those templates. You put in S3 and then deploy it into a stack on CloudFormation. Then you also have to go through and deploy and manage those custom resources. And the way we do this is, we sort of have well-known names for those custom resources based on, what they're managing. But we deploy them and version them and then use a hash of the content as an alias for the version. So when you deploy, you don't have to redeploy it if it's already up there. And you also know that whenever you're deploying, you're using exactly the version that you have available to you to deploy it. So that if you, for some reason, are on an old version and are relying on previous functionality, that sticks around. We have this CloudFormation Lambda library on GitHub that's really handy for this. There's also Go Sparta has just done it for Go. Ours is for Python. Ryan has done it for Python with decorators, if you're into decorators rather than inheritance. So I'm not actually going to cover what our architecture proper looks like. I'm going to talk about this block of text, but this whole thing could be like an hour-long talk. So what we do is we create an application, as I said, microservices, as you do, and we have one stack per microservice. Developer defines a CloudFormation template in YAML, because JSON is terrible, and then we give it this syntactical sugar. So we inject a DynamoDB table in there for service discovery. All these lambdas have to talk to each other in other places, and external services that you may not know at deployment time. You only know that at runtime. So the name of this table gets injected into the lambdas that you deploy, and then they can look up information there after they're deployed. We also let the developer define what resources of these services they want to expose to other services, and what they require from the outside again. Then we have a separate stack for the application as a whole. We have a custom resource for each of these microservice stacks. And what that does is it allows us to create the wiring together of the application there. And then those references go into the custom resource lambdas for these stacks, which populate those DynamoDB tables, and that information propagates back into the service. This also allows us to do cross-service policies based on the dependencies that you declare, so that we can do least privilege on this, so that only the resources that you want to have access, that need access to any given AWS resource, are allowed it. There's no star anywhere. We also handle creating and reusing data sources. So this goes to deployment, which I'll get to next. But sometimes, if you're a developer or you're running an integration test, you want to stand up a pristine environment with all new DynamoDB tables. You want nothing in it. So you want CloudFormation to create one for you. When you're in production and you're creating a new deployment, you want to take all the tables that you already have and are managed externally. You want to reuse them. And so we support that through basically swapping out those resources, like the DynamoDB resource, with a no-op that pulls that information from an existing place. So deployment, this goes back to what A Cloud Guru sort of touched on. How do we actually roll out these updates? So I think this is the biggest area where serverless offerings, not the frameworks themselves, but the actual like AWS offerings, Google offerings, with infrastructure as a service, platform as a service that's lower level, you get a lot of control. You can deploy canaries, you can roll out behind the load balancer, or just create a new instance and direct traffic over. So what can we do with this serverless on AWS today? Well, we can't roll out behind the load balancer because we don't get any control over that. You could deploy in place, but then it's just a big lever that you pull and you get no canaries. It works or it doesn't, and you cross your fingers. So the question is, how do we host multiple versions simultaneously? Well, for API Gateway, you can have multiple versions, and you could make them separate APIs, you can make them separate stages if you want, you get a lot of choice. There's an asterisk here. If you're using a custom domain name, you can't actually have two APIs both allow the same custom domain to use it. So you can't have a DNS server that's responding with different APIs to direct traffic over, because only one of them can own that custom domain name at a time. For IoT, it's even worse. There's one MQTT server per account in a region, and that's all you get. So you're like, okay, well, we'll just have multiple accounts. That will be fine. certificates, the device identities, can only exist in one account in a given region. So you can't, if it tries to connect to another MQTT server in the same region that someone else owns or you own, it doesn't matter. It will just say, sorry. This is a source of frustration for us. So what do? We put a prefix on these topics for the publish-subscribe mechanisms. So all rules on an instance that are listening listen on a prefix topic, except you don't own all the topic names. AWS has its own topics, which is how you interact with the device shadows, the sort of storage piece of IoT. So what we do is there's, in the shadow, in the data itself, we put the prefix in there, and then the rules can actually grab that out of the data when it gets updated. So it's another piece of complexity in there. So then this brings up how do you actually switch the clients over? And this is pretty straightforward if you're not dealing with IoT, but for IoT, because you have devices and apps and you're dealing with these trust issues, we have a separate global API for service discovery using a well-known custom domain. And so then the client service discovery has to return three things: an API gateway base URL, which includes both the host and the stage and maybe a path prefix if you want, who cares? So that allows you to switch out whatever you need. You also have the MQTT host name and that topic prefix. So when an app wants to communicate with a robot, how do we make sure that they're on the same instance so that they can actually talk to each other? So there's separate service discovery for the robots and for the apps. So the robot asks, where should I be in a trusted manner? And then service discovery says, here's the instance I want you to talk to. So the robot then goes and talks to that instance and says, I'm on this instance. I've now updated here. So this is where that topic prefix could change inside that shadow. And that information gets pushed back over to service discovery so that service discovery is aware of it, which means that the app then asks, where is this robot? And the cloud says, oh, it's on this instance. And then they can talk to each other. And this is some sort of weird quadrilateral of trust. We also need a third service discovery because the app has things that it does for itself, not related to any robot. And that could be on an instance separately from all of this because it needs to deal with each of multiple robots independently. So I am actually also going to be early on this. So the awesome, we have 0 unmanaged EC2 instances in our application. That's not really true of our corporate infrastructure. We're not going serverless there, but for our customer-facing application, we are. The good here, the Lambda service in isolation, it scales great. The development is easy. Unit testing is really easy, especially when you use Placebo to stub out your calls, your SDK calls. API Gateway, we like it a lot. We like all the features it has. It's really useful. The Swagger import is now really helping. We also like AWS IoT. So if you're considering IoT, I don't know anyone here, the bring your own certificates that you find almost nowhere. Everyone wants to give you certificates and make you deal with the logistics of getting it, the extra logistics of getting it to your devices. Rules Engine computation is free, does not cost you anything. The pricing is also good even in addition to that. Most IoT services want to charge you per device rather than per usage. But even when we're being charged per usage, we're still below what the per device fees are for a lot of cloud providers. And finally, I just want to plug this because it's kind of awesome and and they're not marketing it well at all. So Cognito just rolled out this thing called Your User Pools. And it's essentially user accounts as a service. And the way that it works is that it basically provides two APIs, an unauthenticated one that the users go up against. So the clients actually contact AWS directly through this, and then an admin API for you to also interact with this service. And it acts as a Cognito user pool, except that it stores credentials for everybody. So, and then when they register, it will contact you with an authorization code that you can transmit back around through the side channel to the user, that they can go back to AWS and say, oh, here, I'm confirmed. You know, iRobot has said I'm okay. And so you never need to handle credentials, and they've thought, like, we've looked at this very closely. They thought through pretty much all the issues. And I would highly recommend using that if you're considering having your own branded accounts. If you're doing federated login, if you're just like, oh, log in with your Facebook, this is not relevant. But if you, for whatever business reason, have to say, you know, we want them to have an account with us, this is the way to go. And hopefully, not 100% sure, but I think you'd be able to pull in Auth0 on top of that to make it part of that unified identity across providers. So, the bad though, deployment gets really complicated. IoT fleet operations on AWS are non-existent. The WAF for API gateway is also, it uses CloudFront, WAF connects to CloudFront. I want that to happen. Integration testing. Haven't really talked about this. How do you chaos monkey a serverless system, right? So, how do I, when I'm deployed, pretend that DynamoDB is having problems? The solution that we're looking at is basically having a wrapper that you can inject around the SDK in Lambda that has a connection out to maybe a DynamoDB table to look up parameters for errors so that it will say, oh, 10% of the time return a 500 from DynamoDB whenever that call is made. That's good for that, but we also have, IoT rules that are feeding directly into Kinesis. How do we don't know what the log messages look like when Kinesis is having trouble because that comes out of the IoT rules, but we can't make it happen. So that's a big area of lacking support. VPC support. It would be really nice to have all of these, all of your Lambda functions exist inside of VPC, or at least have network rules so you can say, oh, you can't actually make calls out to the internet from this Lambda, while it still exists in that ecosystem of AWS services, rather than requiring all these VPC endpoints and all that nonsense. At the same time, we'd also like to so for production, you have a VPC that's sealed, and the only thing sticking out of it is API gateway and IoT. Or pull everything inside the VPC, VPN down to your network, so that your development robots, which are on premises, the traffic from them never leaves your network. This is also handy for us. The ugly, Lambda and SQS integration. It is direly needed, and as I mentioned, the IoT instance certificate thing is sad. So, in conclusion, IoT is complicated, but serverless is the way. Development, deployment, and operations, we're getting those pieces in place, but they're really still just beginning to be solved, I think. Development is obviously the furthest along, and operations is, as usual, sort of lagging behind. Our solution for this is Clouder, which I am hoping will be open source. I have to convince some business people, but I think I'll be successful. On that front, we are iRobot Corporation on GitHub. There's not a lot there at the moment. You can see our CloudFormation custom resource library. We're getting up, they're not up at the moment, SQS Lambda, making it easy for you to set up something that will read from it and fork itself to work on whatever it's reading off. And if you use Active Directory Federation, refreshing your credentials for the command line, we've got something for that. We are hiring, so talk to me if you're interested. And then, yeah, I'm on the Twitter. Thanks.
All right, thank you so much.